Alright, in Concept B, we're going to be looking at some basic information dealing with formulas. We're going to hopefully be able to count the number of atoms of an element present in a compound using the coefficients and subscripts, which you should be able to differentiate between. And we're also going to be talking about empirical formulas and how to determine an empirical formula. So chemical formulas have two purposes. They indicate the amount of elements present in one compound and the amounts of elements present in that compound. So it's giving us what's there and then in what amounts is it there. So the types of formulas, we have two main types to start off with. We have ionic formulas, and we've talked about ionic compounds already. These are made up of ionic bonds. So these are the different combinations that we spoke of. So you want to be looking at table E, especially if it's one of those combinations where it involves the polyatomic ion. And you have to remember that metals are on the left, nonmetals are on the right, so be checking your formulas for that as well for the ionic formulas. Our molecular formulas, which are made up of covalent bonds, these are made up of nonmetals. Just be aware, I pointed this out to you the other day, that the ammonium ion in formulas may look like we have all nonmetals here, okay, but in actuality that NH4 is an ion, which means there's an ionic bond between the polyatomic ion and the nonmetal. So this is ionic and not molecular, even though it does look like we have all nonmetals. Two new formulas, or actually first before we get into that, two things that we pointed out in our first concept. The ionic compounds exist in a lattice, so we always simplify our ionic formulas to the simplest ratio. Molecular compounds exist as individual units, so we don't simplify those formulas. So you can see here C2H4 is exactly what this molecule has, so we leave it as is. We're not going to simplify it, unlike the calcium oxide here, where we do simplify it to the simplest ratio. Alright, two other formulas that you need to be aware of are the empirical formula. This is when we take our molecular formula and we simplify it to the smallest whole number ratios. So glucose C6H12O6 is going to go to CH2O. So I divided all of the subscripts by a common factor of 6, which gave me the 1 to 2 to 1 ratio, which we'll go over a lot more tomorrow in class. The structural formulas, these show the arrangements of atoms within a molecule. So we're going to get more into this when we do our organic chemistry unit where we draw these structural formulas, but I just want you to be aware that it gives that information. It shows exactly how they're arranged within that molecule. Alright, the parts of a formula. There's two important numbers that are going to come up in our chemical formulas. The ones out in front are called coefficients. This 5 means I have 5 water molecules present. And then the 2, which is within the chemical formula, the subscripts means that within one molecule of H2O, I have 2 hydrogens. So let's go over that a little bit more, just so you can get a brief understanding of it, and then we'll practice this more in class. A subscript tells the amount of atoms of the element in one compound. So H2, that's my formula, indicates there are going to be 2 atoms of hydrogen bonded together. For NH3, there indicates that there's 3 atoms of hydrogen and then 1 atom of nitrogen. So again, I'm looking at just one molecule of each of those in order to get it. Now, if an element has no subscript, there's only 1 atom present. So in all of these formulas, we only have 1 carbon or 1 oxygen in our carbon monoxide. In our calcium chloride, I have 1 sodium, 1 chlorine, and so on. Alright, the coefficient, which is a big number out in front, tells us the number of compounds present. The 2H2 indicates that we have 2 compounds of H2, which means within those 2 molecules of H2, we have a total of 4 atoms of hydrogen. So I'm multiplying my coefficient by the element subscript to get the total amount, in this case 4. In addition, here's another example. Here we have 5NH3. This indicates that there are 5 compounds of NH3. I have 1 nitrogen in 1 compound of it, so 5 times 1 is 5. And then I have 3 hydrogens in 1 compound of NH3, so 5 times 3 is 15 atoms of hydrogen present. Alright, so if an element has no coefficient, then it's assumed that there's only 1 compound present. So no numbers out in front. Alright, so this would be a good point for you to pause the video, see if you can try these out on your own and then check your answers. So if you come back and you've seen that carbon, which has 6 atoms in 1 compound, 6 times the 3 compounds present, means we have a total of 18. Hydrogen, we then have, that should say 36 and not 24. So you have 36 hydrogens. Oxygens then is 18 as well. All right, moving along to the other example, we have two calcium fluoride compounds. Calcium, I normally have 1 in one compound, so 2 times 1 gives me 2. And then for the fluoride ions, we have 2 in one compound with 2 compounds present, so 2 times 2 gives me 4 total atoms of fluorine. All right, so you want to get comfortable with doing that because it's going to definitely help you out when we do writing formulas and coming up with the names, and also when we get to balancing equations. So while it seems like a pretty short little concept, you want to get a good handle on being able to determine the amount of atoms in the compound and how to differentiate between our different types of formulas like we did at the beginning of the concept. All right, you are all set.